Everybody, this is Kevin Hallinan. I am the director of University of Dayton's Renewable and Clean Energy Program. Tonight, we have an exciting speaker. His name is Zach Denning. He is the last of our speakers in our spring 2021 Clean Energy Speaker Series. Zach is from California. Did his bachelor's degree at California Maritime Academy, ironically studying and focusing on building energy systems, and spent a career, the early part of his career, in a variety of capacities in the building energy realm, working on building automation and controls, designing systems, monitoring, managing systems. Was involved in sales and a lot of things. And in the course of his work, he saw significant need for improvement, and that's what he's going to be talking about tonight. So welcome again, and it's good to see some new faces here via Zoom, and hopefully some new faces also in YouTube. So thanks again for joining us tonight, and here's Zach. It's going. So Zach, we're recording this. Everybody, thanks for joining us, and here we go. Zach Denning. You got it, Zach.
Awesome. Can you hear me?
Everybody, can you hear?
Yeah, good, so. Good.
I think we're good.
So here to talk about really machine learning in the context of commercial buildings, what we've found, so some of the big discoveries that we've made, and why it's all important. So like, why does it matter now? Like, why is machine learning in buildings so important, and what does it actually mean? You know, a lot of times people look at buildings and it's like, oh, it's just the HVAC or it's just the lighting. And it's just not the case. They're extremely advanced systems. Most energy consumers in an office building outside of just your lights and outlet sockets consume a ton of energy. So quick introduction, who we are. I've spent the majority of my career around smart buildings or building automation systems. Go by a lot of acronyms, BDC, BMS, but they all do the same thing. Essentially, they control the core systems in buildings. This would be your lighting, HVAC, and security are the three, kind of major core systems that we focus on in buildings. I've been all over the industry, done everything from project management, installation, and software, all the way up to sales and working for an OEM for some time. And really kind of noticed this common thread in buildings, and it's really based around the fact that buildings since inception have been physical things, and the people that work in them are really focused on the physical aspect or physical nature of why they run, which is the equipment itself, the wires, the computer hardware. They haven't been focused on software, and we're in an age of software. We have been for a while, and it's an industry that really hasn't evolved with the times, and it's no more prevalent, no more really seen as it is now. And why is it all important? Like, why do we care about these technology systems in buildings? Why can't we just let them stay the way they've been? And it's because $200 billion is spent strictly on commercial HVAC in the United States. So that's the total OPEX and CAPEX budget put together. So that's just the US. It's an insane market that has been completely undervalued. And really it should be a core focus when we talk about things like green energy, climate change. Buildings typically, I mean, they're getting front and center in places like New York and these highly populated, densely populated areas. But what you find is that they consume a lot of energy everywhere. When we break down that $200 billion OPEX and CAPEX, what you start to find is there's tons of losses on the OPEX side of the business for HVAC. They hemorrhage losses, $78 billion of losses annually just in the United States. So when you look at that, obviously a huge breakdown of that is energy consumption. So these buildings run horribly inefficient, and it's not so much because of the equipment, it's because of the software. Again, these are ultra complex systems. You know, you have primary, secondary type systems, sometimes even tertiary. So you have these three different systems layered on top of each other that all have to talk together in order to maintain things like comfort, indoor air quality, and energy efficiency. And what you typically find is the energy efficiency part of these systems has been stripped out. So it's really interesting when people look at this and they go, you know, how is that even possible? We have all these standards. Anybody who's been around green buildings or smart buildings, what you start to realize is there's no such thing as a smart building. You know, we've taken buildings with a 95 plus Energy Star score and increased them to a 98. We've still saved the same amount of money, you know, in these supposed efficient buildings than we have in horribly inefficient or horribly old buildings. So you start to realize there's energy losses across the board, regardless of how old a building is, how new it is, how new a system is, or how old it is. There's always energy savings. There's always these massive energy losses, and it's strictly because of software. So when we see these, you know, 10 or 15-year-old systems, everybody says, oh, that's a really old system. It has an old air handling unit or old unit on the roof, or those are old pumps. And you look at it and you go, yeah, but if you could turn those old pumps off, if you absolutely didn't have to run those old pumps, what are the savings? And they go, oh, you have to run those pumps. And through machine learning and software, we've proven that maybe you don't. Maybe you don't for 3 hours out of the day. Maybe you don't for 2 hours out of the day. Well, you start compounding those savings and it adds up really fast. And that's what we've been able to do collecting the data, is found new ways to save energy with existing equipment. So we hardly ever, if ever, expect clients to replace equipment or do big CapEx upgrades in order to get our software in place. And what that means for us is we're running machine learning on 30-year-old technology, pre-iPhone 1 technology in buildings. So we're enabling them. This would be the equivalent of enabling your 1992 Honda Accord to get 40 miles per gallon from its original OEM spec of only 20, just by tweaking the timing settings in the engine. It's very equivalent. On the other side, and the thing that we always can't forget about, is the service side. So the service industry is still extremely hardware focused right now in the buildings market. I mean, they only care about things that they can see and feel. They don't care about the software. So software obviously gets devalued. The funny thing is, on these new projects, they come in and there's all this sophisticated software to run, you know, energy efficiency measures. And these are the things we're talking about, these clean energy measures, and all these new buildings, they're extremely efficient. Well, they aren't. And the reason is, the second that building goes in and gets signed off on, and all the check boxes are hit on your clean energy and your green energy checklist to make it, you know, LEED Platinum certified and Energy Star compliant, the engineer goes in and turns it all off. Is typically what we find. And so what you're left with is like back to ground zero, you know, back to pneumatics. If anybody has experience with pneumatics, you're left with these really antiquated systems, because the software they're designing right now is a bunch of ladder logic. It's if, then, else sequences. So if this happens, then do this, then do this, then do this. And if you're an engineer and you're looking at this, you're saying, like, how am I supposed to understand all this? It's way too complex. How am I supposed to tune it? What if I get a cold complaint or a hot complaint? What do I do? And even the service technicians, the same guys that installed this original, extremely sophisticated software, don't even know how to maintain it. And so it ends up getting turned off. And so people say, okay, well, you know, smart buildings still make up a huge portion of the market, you know, so a lot of buildings are getting phased out, right? They're turning over. And even beside the fact that they're impossible to maintain when they get installed, what you find is that new construction makes up less than 3% of the total buildings market. Of that construction, the most interesting part is they're not building skyscrapers anymore. They're building suburban office buildings. So suburban office buildings are not considered smart. They're not put, these really sophisticated systems don't go in. They're typically not LEED Platinum. And there's typically nobody's there saying, hey, you know, you're green energy certified, you're Energy Star certified. They just throw these systems in and walk away. So even though on some of these systems, they have really advanced software and sequences and everything, that eventually just gets turned off. In the majority of buildings that are getting built today, they don't have anything advanced in them. They're literally just turning them off and on. They're not even doing that correctly. So as a result of that, you also have these huge compounding service issues in the industry right now, where you're sending out hardware-focused technicians that typically don't understand software, and they're sending them into these scenarios saying, like, basically tune software, and they don't know how. And what they're doing is just replacing parts instead. So this would be the equivalent of you driving your car up to get it maintained, and the guy goes, you need a new alternator. And he just pops the hood and says right away, you need a new alternator, and he swaps the alternator out, hits you with a $300 bill, and you go, I mean, I had to check engine light. Did you at least plug in and see what it meant? He goes, no, it was probably just your alternator. And that's how the service industry right now for commercial offices is based. Guys go in and just replace parts. because they don't understand the software, they don't want to get into it, they don't know anything about it. And so you're looking at this really hardware-focused industry where even if they have software, it's usually too complex, and so it gets dumbed down, you know, or you're just dealing with software that was already really dumbed down. So what we look at here at Hank is there's no such thing as a smart building. The smart buildings industry is fluff. It's something that's been, you know, built up in people's minds that it exists, when in reality, we still have yet to run into a smart building, and we've taken on buildings of all sizes up to 500,000 to 1 million square feet. And we've saved the same proportional amount of energy in all of them, despite all these factors that make them smart. And so you say, like, how did we get here? Like, why did this happen? And what you really have to go back and look at is the supply chain and how it's evolved over the years, and why products have failed so far to deliver on a solution that we're having a lot of success with. And when you look at the top of that supply chain here, at the very top, you have commercial building owners that own the equipment, in this case, the broken equipment, because it typically is when we get into these buildings. You know, these are the owners that care about the asset. That is the asset manager, or the asset part. They care about how much money it spends and how much money does it take to manage or service it. And then if it needs to be replaced, I have to deal with all the CapEx. The property manager is fiscally responsible for maintaining that budget. So they get a budget from the owner, they maintain the budget. The problem with property managers that we run into when we talk about sophisticated software and building management is they know very little about HVAC as a technical resource or technical gatekeeper. They're typically not that level of technical expertise. So as far as technical decisions, they're usually not going to buy in. And they're just now converting from pen and paper to cloud-based technologies. So they're really not somebody that's going to sign off on, hey, there's this new advanced software, I need to save a lot of money. The other thing that we find with property managers often is they're a top-of-the-line service, meaning as long as the tenant's there and they're paying their lease, they're getting paid a proportional amount to that lease. So as far as trying to drive OpEx savings, they're typically not financially incentivized to do that. Now, they're financially incentivized to meet their budget, which was determined by the owner, but they're not financially incentivized to drive that budget lower, especially if it comes at the expense of a tenant being mad, maybe not paying rent because of comfort issues. So they're very risk averse. When we look at building engineers, everybody says, okay, well, what about building engineers? There's very few building engineers left in the United States on a per building basis. So right now it's like 100 to 1, for example, if you're looking at buildings over 50,000 square feet. That means there's very, very few of them. Now, if you look at the talent pool side, it's also a very small talent pool because it is blue collar work. The blue collar workforce in the United States is drastically dropping, as most of us know. So as a result, very few engineers and even fewer that have the technical expertise to work on building automation or smart building systems. But they're really good at fixing things. So if you tell them to go do something and, hey, I got this box or this unit that's not controlling correctly, here's 3 things that you need to go check out based on the data. Can you help us out with that? We found that they're very amenable to that. They're totally willing to work with us, which is a great relationship that we found. When we look at HVAC contractors, these are the guys that come out to replace the units, maybe service them if there's not a building engineer on staff, which is becoming more and more of a rarity. Now you have an HVAC contractor. This is the guy that installed the system. Maybe this is the guy that did all the sheet metal, maybe even wired it in, but not traditionally a software specialist. Maybe a design engineer, but that's somebody who just designs systems. That's not really somebody who tweaks the settings and does the software aspect of it. And that's where you arrive at building automation. And that's where we kind of get back to this is the smart buildings contractor. What a lot of people don't know is these people were actually born out of HVAC contractors. So HVAC contractors used to manage, the full end-to-end product when it came to HVAC. They used to do all the controls. They used to do all the installations. So they managed kind of both aspects of it. But as the control got more sophisticated, as we moved into electronic systems and the rise of computers throughout like the 80s and 90s, building automation became its own thing. It kind of spooled from these HVAC contractors. And, what we find is, there's still this perspective of hardware is we still have to sell hardware. It also now becomes this weird point for customers and everybody up the supply chain is like, who's actually in charge of how the equipment operates? Now you have this guy over here that's kind of doing the controls, kind of doing some of the hardware and doing a lot of the software. And you have a guy over here kind of doing some of the controls, kind of doing some of the hardware. And so you end up with this kind of split decision between who's actually responsible when things go wrong. You add a building engineer to the mix and now it becomes just a blunder. So to try and reason through all that, they introduced analytics. So if anybody's ever heard of analytics or they have a bunch of different names, alarming, analytics, overlay, front end. That's where this is introduced from. Is hopefully this is kind of that binding force of software that can bind together these three different individuals. So yeah, your building engineer, HVAC contractor, building automation. We'll bind them together through one core piece of software that's going to tell everybody all these magical things and what to do. And what you find is it just never progresses through the supply chain. So analytics have been around for a long time, since the early 2000s, in the internet bubble, and they've never caught hold. And they've never caught hold because they don't really drive true value. There's not long-term value in them. Yeah, they find some broken components, but they don't fix anything. They don't fix the software. What you find in buildings is that 80 to 90% of issues that relate to comfort or service are actually software issues, not hardware. So when you bolt on a software package to find software problems, it has to be able to solve those problems. And that's the big fall down point that we find in analytics is it doesn't solve anything. It doesn't solve the majority of issues, which means it has very little payback to customers. And as a result, it typically gets dropped after they find the hardware issues. I mean, the funny thing that we find too is customers already know about their hardware issues. There's not some magical software that you can put into a building to tell a customer to buy a new $50,000 unit. They just have to buy the unit. And so you kind of add the software in, and in essence, it's almost like selling insurance, is what we find, which nobody really wants to buy unless they've had some catastrophic failure, in which case they may buy it, but they're going to buy the bottom dollar solution. And this is your solutions right now. This is the array of solutions you have to manage HVAC. And every person basically has their own ownership. And that's where we typically find is that nobody wants ownership. And so, it's really a problem of not so much software, but even as much as a broken supply chain, and who has ownership. The funny thing is everybody always goes back and they go, yeah, but they're still smart buildings. They're still building automation. And you have all these companies that have predicated, their entire business model, tons of money of investment, and R&D, and building automation is not the solution. And that's what the analogy we always use is building automation is essentially Dell in the 90s. No offense to Dell, they make amazing hardware, but you had this rise of big cloud hosting in the early 2000s. You born the Google Cloud out of it, where if I'm running a business, I don't need to pay for a $25,000 data center in the middle of my office anymore, that Dell hosts, and there's a technician that comes out that has to work on it all the time. I just put things into the cloud. And that's where we find the building market is really headed now, is this divergence of hardware and software, where it's no longer this one person, just like in the 90s, you had a data center guy or a tech guy come out to your office and work on your data center. You now have everything in the cloud. It's much more centralized, it's easier to manage, and it's cheaper. And that's what we're finding with building automation. And just for example, this is what we typically find with building automation. Everybody says, why isn't it the future? Because this is your future that you're looking at. This is your smart building, by the way. So for the average person that says, what about smart buildings? That's about as smart as it gets. In case you're wondering, that is likely a Dell with a CD and a floppy drive, or sorry, that's not floppy, but it's close. We do find floppy drives still in them, and that's Windows XP. So it's not an exaggeration. 75% of the business or the buildings that we've gotten in have been Windows XP. We can barely even load them with software to do remote desktop, for example, if we have to do configuration. So this is the future of buildings right now. It is not changing. We recently had one of our customers come back and say, a contractor, building automation contractor, told us that if this computer dies, we lose everything. And it's like, well, that's a problem for your smart building. And it's a problem because they're also paying, an OpEx cost well over $200,000 to $300,000 a year for their HVAC, and it's run on Windows XP. So this is where we start to learn that, there has to be a better way. There has to be something beyond this, in order to properly maintain these buildings. And it's not sophisticated software. It's not writing ultra sophisticated software that nobody understands. It has to be software that's actually self-tuning. And that's where we get into virtual building engineering and the service that we offer. So we feel like this is where the industry is headed. You have a shortage of building engineers right now. You have contractors charging too much money. You have integrated hardware and software. Looks like I got.
Save it.
Yeah, Kevin, do you mind if I just tackle these at the end?
Yeah, tackle them at the end.
Awesome. Yeah, anybody else that has questions, feel free to throw them into the message, send them over to me, and I'll definitely tackle them at the end. So so what we feel like is you have the shortness of engineering, you have really old hardware that's not being replaced anytime soon, you have really old software that nobody knows how to maintain, and anybody that tries to build up solutions right now uses very sophisticated software, and we don't think that's the solution either. It has to be an end-to-end service. And so we've branded it Virtual Building Engineering, and it's end-to-end HVAC management. It's powered through machine learning. It's a machine-powered AI that we use. It does 90 to 95% of the work, but we still have humans on this end. We still have engineers on this end that look at data, answer alarms, and work with customers in order to find solutions to problems. The beauty of virtual building engineering, though, is we find the actual root of the problem within about 10 minutes of actually getting an alarm, and we can find the root of a problem. So we're not going out there, popping the hood of the car, foraging around all the components to see what might be failed and listening to everything. It literally is, hey, your check engine light now tells you you need to go pull into the next stop because your alternator is starting to wear out. It's probably going to wear out in the next 100 miles. It's going to cost you about $90 to replace. Here's 3 shops that you can stop at that are willing to replace this for you. That is the future of buildings, and that's what we're already creating and we're giving to our customers right now. So what does it mean? There's a lot of systems out there. So we've been working on this for a while. We've been in it for over 3 years now. And really for the first year and a half, we worked on integration. We built drivers, methodologies. We've integrated over 30 different types of systems. So this would mean that you could put Hank in just about every car ever made. At this point, Hank would bolt into every car ever made and be able to optimize that car for gas mileage, rideability, ride quality, a bunch of other things. But we have integrated to a lot, and I think that's really a precedent to set because you have a lot of old systems. Like we found one manufacturer has 7 different flavors of their system, ranging from things they built in the late 90s to things they're building today, and they all integrate differently, and we had to integrate with all of them. So 30 manufacturers may mean 3 different variations of control systems per manufacturer. So you can see how quickly and how deep it goes, and we've built literally automated solutions for each one of those manufacturers that can bring in points and do integrations for us. So we can get onboarded extremely fast. Our average onboard time is less than 2 weeks. In comparison, it takes a controls contractor about 3 to 4 months to get onboarded into a new building and do an integration. It's something we can do in a matter of 1 to 2 weeks. So it's extremely fast. Not to mention, we have this whole huge array of methodologies, drivers, implementation paths, to get on board with any customer, any control system extremely fast. Obviously, the things that customers focus on most, what generates our ROI that makes it a valuable product from the onset is the energy reduction. We looked at over 60% HVAC energy reduction alone. When we get into lighting, we can compound on that. But what that basically means is we're saving anywhere from 20 to 25% total energy reduction per bill for customers. The interesting part is we don't do all the voodoo of weather normalization and all these other things the energy services contractors do, or ESCOs. We do bill on bill, and we can prove it month over month. And if you want to do the weather normalized, it's great. Our savings actually go up, but bill on bill savings, we're doing over 20%. And that's with the same occupancy, similar weather. I mean, we'll break it down for clients however they want, but it always exceeds 20% is basically what it comes down to. At 20%, that means we have a massive ROI on our products, over 100% month over month, meaning the customer is making the whole return of what they spent on us in whole. So not only are they breaking cash flow positive, they're saving double. So to date, it's the best real estate investment that you can make because the ROI is immediate and it's huge. The other side of it, obviously, on when you talk about the cost savings, we reduce on-site service by over 80%. The average building you walk into right now has 4 to 6 service calls a month that they usually deal with. Those service calls range from $500 to $1,000 a piece, and they typically don't replace anything. These are strictly somebody going on site messing with the software. So you could be spending anywhere from $3,000 to $5,000 a month. Under Hank Control, you're spending anywhere from $500 to $1,000. And that's usually because we find things that are either going to break or are already broken, but nobody knew about because they didn't get comfort complaints. So this is machine learning driven monitoring. This is where we actually have engineers in front of a console all day that look at alarms. The alarms are actually generated through machine learning. And they spit out and say, hey, I think there's a problem here because this, and this. And the engineer looks at it, approves the alarm, and coordinates the repair with the customer. When you look at why now from an asset manager perspective, which is really what this is, why this is so important, NOI has increased by more than 20%. So when you look at buildings as an asset class, they generate anywhere from, maybe 12 to 16% ROI year over year. So what we're looking at is we can increase your your NOI, net operating income. We can decrease that pretty drastically. We can actually increase your ROI by an extra 2 or 3%. And that may not seem like a lot, but when you look at an asset class that's only generating 15% returns, being able to generate another 2 to 3% makes it almost a completely different investment class. So it's really interesting what we're able to do with cost savings. If you look at both the service side and energy reduction compounded together, it can be anywhere from a 4 to 6x ROI month over month on our product. It gets very, very massive, very fast, which is really exciting for us. Everybody goes back to like, how does it work? We assemble our own router in-house and we script it. We don't manufacture. We're not a manufacturer. We just take off the shelf of components. We build our own casing and we assemble it all. It comes with its own 4G LTE, so we don't have to rely on anybody else for internet access. Surprisingly, in most of your smart buildings, only about half of all buildings have internet access. So people don't realize that most buildings aren't even connected to the internet because if you have Windows XP, highly volatile, can get hacked very easily. So they've actually pulled them off the internet in most cases or in some cases. So we actually have to have internet coupled to ours. We do all of our own internet security. We have our own team here that manage it. So everything's firewalled, everything's behind a VPN, and we maintain our own 4G. We literally ship it to a customer, they plug it into their system like it's Comcast. From there, we do all the other setup remote. So we can set up their internet. So we can usually not set up, surprisingly enough. Their internet's not set up. So we'll set up their internet. We'll actually get all their stuff communicating. We'll do whatever it takes to integrate and get bidirectional data transfers. Now we're actually talking to their HVAC, their lighting, in some cases even their security system, all in the same networking infrastructure. From there, what we do is we set up our box. So it's starting to communicate, and then we set up what we call digital twins in the cloud. So digital twin is a combination of multiple machine learning models. So it can be everything from alarming machine learning that's strictly looking for failed components. So, okay, this isn't working right. It can be comparative. So I'm looking at surrounding equipment like me and trying to find problems with myself based on how surrounding equipment is working. So comparative historical alarms. So it's a combination of all these things: alarming, machine learning, and control. And so we actually have control machine learning that'll take full control of a piece of equipment using strictly machine learning. So it'll actually control, how much air comes in your office, how cold that air is, for example, or how hot it is. That can be controlled strictly from machine learning. And so these are what we call digital twins. We take all the sizing, the manufacturer spec for the component, and we inject it into the digital twin so they can start learning how it should control. We do run an ASHI level 2 audit with our software. What that does is it's going to go out, collect all the data, and it runs itself in monitoring mode. And during this time, it says, okay, based on my digital twin, I would normally be doing this with the equipment. It's actually doing this. And if you do it my way, this is how much money you're going to save. It also does is find hardware issues. So it's actually saying like, hey, you're trying to modulate this specific feature. It's not modulating. Because of that, there's a 90% chance or whatever rate it's working on of failure. Then it spits it out to our engineer, and our engineer approves it and says, yes, this is a failure. We present that audit to customers to show them how much money they're going to save. It's all integrated with our software. So they literally open up our software and they can sift through it to see how much they're going to save, why they're going to save it, and what their system's currently doing. And so it's a really direct way for customers to understand this is what Hank's going to do. It's also a way for all those stakeholders that you saw before to understand what Hank's going to do. So we can get the HVAC contractor on board. We can get the asset manager, the property manager, the building engineer. It's a way to show them this is what we're going to do. It kind of alleviates some of the stress of maybe an AI or machine learning taking over a building, which may be stressful or complicated to understand. Really simplifies the process for them, gets them on board. From there, we actually take control. And so from what it's learned during the audit process, it can usually take control in less than 3 or 4 days. During this time, what it's going to do is it's actually going to notify one of our engineers, hey, I'm ready to take control of this piece of equipment, like an air handler, or a pump, or a boiler, or a chiller. I'm going to take over using machine learning. It notifies them, they log in, they make sure it's making the right choices, and then they approve it, and it takes over. And so throughout the life cycle of a building setting itself up, this is what it'll do. So when we talk about things like, when we talk about things like commissioning, CX commissioning, building commissioning, it does its own commissioning. If one of our engineers is sitting at a console, it'll spit out, hey, I'm having a problem with this set point. We'll go in, we'll look at the data, we'll see why or why not it's making the right decision. And normal commissioning, you have to sit through all these lines of code, all this crazy logic. It's multiple stakeholders, contractors, building automation, commissioning agents, engineers, all trying to look over the data as fast as they can to come to conclusions on why it should be operating a specific way. In that context, insanely expensive, and they're taking it only in light of or in lieu of the one season in which they're commissioning. It's not continually doing this. With ours, it'll continually learn, and as it finds problems, it'll spit it out. So I think it's really interesting when we talk about things like commissioning for people to understand commissioning. We actually just partnered up with a prominent design firm out of the Bay Area right now, and they pointed out, it's like, do we have to do commissioning anymore? And we said, no. And they're like, that's $30,000. And like, yeah, you don't have to do it. We'll do it. We'll do it because we're going to continue to do it throughout the life cycle of the building. So everybody always talks about, like, why is this happening now? Where are we headed? And, where is this divergence coming from? And you find a lot of different things happening right now in the building space as to, why virtual building engineering is going to be a thing. It's not going to take the place of building engineers. We 100% need the engineers that we work with in buildings. They're fantastic. They maintain the hardware aspect of the building. It's like on-call hardware changes that we need or repairs we get. So tenants stay extremely happy and buildings stay extremely efficient. So we love building engineers. Building engineers love us. We work with them a lot. I'd say in at least 4 out of 5 of our buildings that are over 150,000 square feet, we work with engineers. So they're not going anywhere, but they're heavily reduced. So we know every year it's something like 5,000 engineers or 1,000 engineers. It's a big number if you look at it as a whole, are leaving the industry. I think it's like 2,500 engineers are leaving the industry every year. So you're only dealing with like 15 or 20,000 engineers or a small fractional number like that. Again, it's like 100 to 1 for buildings right now. That many engineers, leaving is a big deal. It means we're going to run out of engineers. I went to school for building engineering, and it's amazing to see like how small the class sizes are even getting at the school, even talking to them still. So that's what you start to learn is we have this huge reduction of workforce. This is an inevitability. HVAC contractors, very challenging because they're outsourced. It costs a lot more money for them to run these big buildings. They're essentially putting their own engineer in these buildings at 2 or 3x the cost of a building engineer. So we're running into this place right now of, why can't technology take a lot of that workload? And that's what we're finding. Occupancies are starting to fluctuate. So we do have this fluctuation, this change of how buildings are utilized. A lot of people feel like buildings are moving in a direction where it's going to be more like 24-hour fitness or a gym membership where you check in, you find a seat, you find an office, and you go. And so you have this variability right now of maybe not as many leases as far as like leasing out a suite is concerned. Suites might go away or start to go away. We might move towards that remote workforce or remote office. It's starting to kind of finagle in that direction more and more the more reports we read. So that is changing. Occupancy are changing pretty drastically. Current systems are still like 20 years old. So you still see like Windows XP all the time, and these old technology costs owners a fortune to upgrade them. You're looking at in an average building anywhere from $2 to $3 a square foot to upgrade these systems. It is too expensive, and you're not really getting any payback. And you're looking at things like indoor air quality now, where like everybody wants to understand indoor air quality. Am I getting fresh air in my buildings? You walk in these buildings, and the most of them, the answer is no. You're nowhere near fresh air requirements based on, California Title 24 standards from ASHRAE, for example. You're nowhere near it. And this could mean like some buildings aren't getting any fresh air. So we're really far away in a pre-COVID setting. We really need to get back to like where fresh air means a lot to get people back into the office, which is where building owners want to be. So we're actually guaranteeing indoor air quality. We've written quite a few heavily involved algorithms in order to figure out, are we actually achieving indoor air quality standards? And we're actually increasing outside airflow in some cases by up to 30 to 50%. It's pretty drastic, and we're still getting the savings. So kind of anomaly. We talked about CapEx budgets. These systems are too old. It costs way too much money to swap them out. Owners aren't interested in CapEx budgets anymore. They're really moving everything towards OpEx. And we're really seeing that as a testament to how fast we're expanding right now. People don't want technicians on site. This is another big thing of people don't want people there. You don't want to see physical people in your space anymore. So when we talk about, hey, I'll just go pop a tile and I'll get above your ceiling, they don't want that. You have to get to the root of the problem. And especially if the majority of your problems are software related, you should really get to the root and fix the problem. Our SLA is something like 15 minutes right now, and we usually resolve most problems within 10. So we're looking at like less than a half-hour time from problem discovery to resolution. Whereas right now that's like 3 days with somebody in the space popping a ceiling tile for nearly absolutely no reason most of the time. So we're starting to see people push back. I don't want that person in the space. If they do have to be in the space, can it be scheduled? Well, if you know ahead of time something's going to fail, you can actually schedule somebody to be in the space. So really this interesting transition as we transition more and more away of our own, physical stuff and people being physically in the space and people just not wanting that. And then obviously, operational expenses with the whole COVID cleaning, who's going to be in there, what are they going to be doing, and really why are they going to be there? So that's what I got. Thought I'd leave some time open for any questions. So it looks like Kevin, you already had one.
Zach,
So when
this is Kevin Hallinan. I have just a comment. So I'm a big fan of LeBron James, who's out your way. But you're almost like LeBron James to me. I just saw genius in everything that you've done. Hey, let me just ask the question that I shared with you via chat. I've noticed that energy services companies often spend a long time trying to figure out when they enter a new building and they're trying to figure out the controls. They spend weeks, months trying to figure out what the measurements are, where they go, what location does this measurement point come from, et cetera, et cetera. How are you guys mitigating that?
Yeah, so looking at it from a technical perspective, if I'm an energy services contractor and I get into a building, I got to figure out, kind of everything. I got to figure out is the hardware working right, is the software working right. I got to then convince an owner to buy into a long-term engagement that is going to return enough money that there's meat on the bone for me, which is a pretty challenging place to be in, I'd say, right now in buildings. So when you look at it too, is I have to continually make sure that building saves energy over time. So not only am I going to get hit with a big CapEx I'm going to finance for the owner that has to be cash flow positive, I have to ensure long-term it's going to be cash flow positive. And so there are these huge projects. Like you look at like 6 months onboardings, having to work through tons of contract details and everything else. And then at the end, they still have to make sure it's actually going to keep performing. If we go back to the fact that the majority of buildings work wrong because of software. So if you start to believe that, which I'm a strong believer because I've seen it now so many times, what you start to realize is the majority of the work the ESCO is going to have to do to save energy is going to be software related, not hardware, which means that they typically don't have that software guy in-house. So they're outsourcing it to the building automation guy who is now profiteering off the work. So it's actually in his best interest to drive more costs back into the project and make money off of it. That's how he makes money. He's monetizing the relationship. And so it ends up being this huge built out thing. Well, now I have to go hire an engineer to do commissioning and make sure it's gonna work right. I gotta hire this software HVAC controls guy or building automation guy to do the work. And then at the end, I have to make sure it all works right. So I have to do some commissioning on the back end. It becomes this hugely involved thing. The reality is he probably could have hit 80 to 90% of his savings if he just fixed the software originally, because the software isn't working right. And that's what we've learned is using machine learning, we can shortcut the whole process. We also do our own engineering, meaning if something doesn't work right, we'll re-engineer it ourselves. We don't wait around for a design engineer to come in and tell us what to do. We don't wait around for a commissioning agent to commission it. We have our own design engineers in-house. We know how HVAC systems work. We'll redesign them ourselves on the fly, and we'll then teach the machine learning how to tune those systems. So, compared to an energy services contractor, we're shortcutting the whole design process. We're reusing the equipment, so we're not trying to throw in a bunch of new equipment and really, I'd say, pollute the water even more. We're strictly learning how it works now. We're looking at the design and seeing if we can re-engineer it using software, which most of the time we can. We're teaching the AI how to then control it to that new engineering spec. and then we let it take off and run. And then what we typically find is that, within 4 days worth of data, it can get 80 to 90% accurate, which is more than enough to maintain comfort and get a substantial amount of energy savings. You give it 2 weeks, now it's 90 to 95% accurate, and the energy savings are through the roof. Which is really why long-term we look at it and we say, okay, we don't have to have normalized weather and all these things. I'm not monetizing the client savings. I'm a flat subscription fee. So if you save 2x versus 3x or 4x, 2x is still fantastic. I don't have to prove out further savings. I'm not tied to the savings. I'm not coupled to that. I'm not monetizing that aspect of the relationship, which I think is also a reason why we're so aligned with owners, is we're aligned with working with them through problems, not monetizing every aspect of the relationship. And ESCO is monetizing the relationship. The more energy saved, the more money they get paid. So they're not there to support your comfort. That becomes a necessity. They're not there to support indoor air quality. That's just a necessity. So they're going to push those things as hard as they can. And I think that's also what contributes to why it takes them so long, is they're always pushing the threshold of what's comfortable. And that's why I think you get such a pushback with owners against ESCOs too, is like, you're just going to come in and mess up comfort. And comfort's how I get paid. That's why people sign leases, is they stay comfortable. So again, I think energy service contractors are still in a high conflict with owners, because there's this mentality around, to save energy, you're going to ditch comfort. But if you think about an engineer, and now we introduce an engineer saying, we're virtual engineering, well, engineers solve all my problems. Right? An engineer cares about comfort, indoor air quality, and energy. They have to. That's part of their job, because they're aligned with ownership groups. So long story short, I'd say like energy services contractors, at least from the point, when you look at from a customer perspective or customer facing perspective, they're not aligned. Or an asset manager, I mean, maybe they're aligned. From a property manager, absolutely not. And that's where they've kind of gotten a bad rap. But even more importantly is, like, you look long term, and they're messing with set points. They're messing with things that, even if they got the system to work really efficiently, it's typically, at the sacrifice of comfort, or at the sacrifice of indoor air quality.
Hey, Zach, thanks. We'll open it up for questions, but before we do, let's give Zach a hand, if you could. Yeah, or at least a virtual
Thanks.
thumbs up, something like that. So questions, folks. Hey, it's good to see a lot of new people tonight. So yeah, questions. Feel free, just chime in, unmute, chime in.
It looks like Nicholas. Oh, Andrew, you have a question?
Yeah, I have a question.
Yeah.
First of all, Kevin's got the sport all wrong. It's not LeBron James out there in California. It should be like Wayne Gretzky. He went out to play hockey.
There you go.
Yeah.
There you go. I'm not a huge LeBron fan, so unfortunately, I'm not a monster LeBron fan. I mean,
I'm sorry, I don't like you anymore.
Oh, great presentation. Hey, we do building energy audits. So I was wondering if you had a hard and fast rule of a cutoff, like size of a building and HVAC systems. But also, I always thought there was a big market, untapped market for small buildings that have like packaged rooftops that don't have the money or the time to put in a sophisticated building automation system. So do you see any opportunities with those types of buildings?
yeah.
And what's your cutoff for the big buildings too? So 2 questions.
Yeah, so our small cutoff is 30,000 square feet. You typically find below 30,000, they don't have a building automation system. There's nothing to plug into. They just have thermostats on a wall. We don't focus on light commercial. There's some savings there but from a software perspective, it's very minimal. It'd have to be at scale. So you'd have to have, 100, 200 package units like a mall, for example, to make it worthwhile for us. And we have explored those relationships because we work with large property investment funds that have diversified a little bit into light commercial. So we have talked about it. We just haven't put together that solution yet in its entirety. So in a short answer, 30,000 square feet is the bottom cutoff. We won't do below that. And the economics start to get a little interesting around like 30 to 50,000 square feet. We're still cash flow positive, but you're not looking at the big, 4x return. You're looking at something, sub 100% month over month ROI. So you still may be floating 30 to 50% ROI, but then you're talking about hundreds of dollars, not thousands anymore. So I guess it just depends. We find a lot of our contracts below 30,000 square feet I either go upgrade my control system, which is going to cost me $30,000, or I go with you, which is cash flow positive. I'll go this direction that's cash flow positive. And that's how we pick up a lot of our clients that are, sub 50,000 square feet. We do run audits for net new customers. So typically with the audit that we talked about, that's net new customer. And it's the equivalent of an ASHRAE level 2 audit. It'll go find everything without boots on the ground. You start talking about like ASHRAE level 3 audit, it's a guy walking around the building saying, well, the economizers aren't really working. We can use machine learning and data to figure out there's an 85 to 95% confidence that the economizers aren't working. You should probably go check those. Very simple fix. A good example, we got into a building, we fired it up, and we kept having these economizer alarms coming in that were machine learning driven. Guy was up on the roof. We found a cooling command failure with one of the units. So one of the stages of cooling had gone out. We also found out with machine learning. We told the contractor or customer to put in a work order. They did. They sent him to the roof. We said, make sure he calls us when he gets there. So he did. And we said, hey, while you're there, can you check out the economizers? We've been having issues with them. So we walked over and he goes, oh, all the linkages are loose. Looks like nobody ever tightened the linkages or commissioned them basically when they installed the units 5 years ago. We said, great. There's 10 units on the roof. If I go get this approved through the owner, can you do all 10? He said, for sure. We went back to the owner that day, said, you're going to save $100 a day if you get him to do this. And it's probably going to cost you another couple $100. Like I was like, for sure. So we walked around, did all 15. They started saving an additional, I want to say like $900 to $1,000 a month, if not more. And it costed them like $200. So we do the audits. We actually started as a company that only did remote virtual audits. That's where we wrote all the machine learning to begin with. And we won a grant to prove that we can connect the machine learning that does the audit to the actual control to fix the problem. Because we figured out the majority of problems were just software related, not hardware. So we still run the audit for net new customers on at least 1 or 2 of their buildings to prove out what Hank's going to do. Typically after that, customers just progress their portfolio with us. So they give us the rest of the buildings in their portfolio. We proved it once, we can prove it in all of them. And when you have a 2 or 3x month-over-month return, even if we went down to 1 to 2 with a customer, it's still ridiculous compared to what they're spending money on right now.
Cool, thanks.
Yeah.
Other questions, folks?
Oh, and the building size goes up to whatever. We just did audits in 800,000 square foot buildings. Those have full-time, that's a full-time engineering staff. They have 3 on-site engineers. We did 800,000. We're looking at saving them about $23,000 to $24,000 a month with full on-site and a control system that's only like 5 years old, 6 years old now. They just replaced it. So, other questions?
Zach, I have one. So we have a lot of young people. We have a lot of young people here with us tonight, and visiting with us via the recording that we're going to host. I guess where you're at now relative to where you were when you started your career. What advice do you have for young people coming in?
Yeah, that's a good one. Well, I'm somebody that's been beat back by the smart building industry time and time again. So I was the guy, I was the squeaky wheel that always said, like, this is software, guys. This isn't hardware. This is software. You guys are talking about a software problem, not hardware. And nobody would listen to me. And it became just this perpetual thing in my career. I did smart buildings for like 8 years, and I worked across the whole spectrum. I started a division of a mechanical contractor. I did sales. I did project management. I did the software itself. And it was always the problem of, I want to go sell a CapEx project. I want you to go sell a CapEx project. That's where we make our money. We don't make money in software. Stop talking about software. I've pitched this idea to friends that I grew up in the industry with that are 8, 9, 10-year guys with me, saying, like, you and I both know this is going to be the future. So how about we do this? How about you resell my product? And they say the same thing. I can't make money. I just can't make money. It's like selling software to an IT professional in the 90s. They're going to pay to pound sand. And so you hear enough that you're wrong, and it's only one of 2 things. Either you're actually wrong and you're just the loud person in the room, or you're actually right, and you should go start a business. And so for 8 years I heard it, and I really started it, I just started the bones of it while I was working for another company. And You know, I went around, I tested the water with customers. I talked to real people. I went out and found property managers. I went out and found building owners. I went out and found people in the industry. I went and talked to contractors. If something like this was created, would you actually buy it? The overwhelming answer was no, which was like music to my ears every time they told me no. Because it means they wouldn't rep a product like this, which means they wouldn't build a product like this, which means I'd have little competition. And so I'd say, like, you know, launch out in your career, but if you're always that person, if you're always the contrarian, and you're constantly saying like this isn't the way to do business, then you're probably right. And at least it's worth trying your hand at. And I would just say, go talk to people. You know, if you think you're that right, prove it, right? Prove it to yourself. Don't just quit and think you're right because you may be wrong. Like, use your platform, go talk to people and see how right you are. And that's what I did with this. And after a while, it became overwhelming that, like, this has to be the way. And I don't care how many customers even that I talk to tell me, oh, this isn't right, or, you know, this or that. I know this is the future. This is the way things are going to happen. And I have that conviction. And so I'd say anybody that, you know, if you continually become the contrarian at your company, it means your company is not doing it right. I mean, I worked with a lot of companies and they were all telling me I was doing the wrong thing. And I come here and we're really successful. We're growing extremely fast. And we're taking accounts from a lot of those companies now. Those, you know, and so now it's like, okay, well, this is kind of the proof. So it's like that age-old thing, you know, when they talk about startups and entrepreneurialism and everything else, that, you know, likely if you think you're right and you have a lot of conviction, it's because you are. And so I'd say to definitely do that. And it takes a long time too. So anybody who thinks that startups happen overnight is psychotic. Anything, you know, thinks success happens overnight, you're crazy. It takes a lot of people. You have to get a lot of people to believe in what you're doing. They have to have the same conviction as you. So you have to get really good at selling this dream, even if it's not completed, even if it's not perfect. You have to go out and sell the dream to other people, because businesses aren't made with one person. They're made with a group of people who believe the same thing, and are willing to do anything to see that belief come to fruition. And so I say that's the other thing, is even, you know, now you have your idea and you have the conviction, you have to get other people to believe it too. So you have to start selling the dream. Not only to customers, you have to sell the dream internally to people to help you build that dream. So, you know, so everybody that thinks that, you know, these companies just sprout up out of nowhere, you know, you're horribly wrong. It takes a long time, a lot of effort, and a lot of work to understand why your product should exist, why your service should exist, and where it should exist, and to find that beachhead customer. The first customer who writes the check means you're a real thing. You're not a real thing until people are willing to pay money for it and write the check. Once they are, then it's just figuring out, you know, who are those customers and where are they at? And we've done a really good job of that. We have a really good team here, and we've been able to grow rapidly because we understand that extremely well.
Hey, everybody, this is Kevin Hallinan again. I just want to say we're at the end of our time. I hope you appreciated that this was a really great talk. Zach, I don't know, in my 30-year career, this is maybe one of the best I've ever heard. So I really,
awesome. Yeah, I really
appreciate it. And I just want to emphasize to everyone that we had this clean energy speaker series this spring. We're going to be doing it again in the fall and all next academic year. And hope we see you then. If anybody has any question about energy careers and curriculum, jobs, internships, I just chatted my email address. If we could close this with really just giving a thumbs up to Zach, or if you can, if you know how to do that in Zoom, something, or a hand. Really, really good. Zach, great talk. Thank you so much.
Awesome.
You're our last speaker for the year, and honestly, it's been a super year for folks here. So
awesome.
Hey, everybody, thanks for joining us tonight. Have a good evening. Zach, you got a second?
Kevin. Thanks, everyone.
Just a bit afterwards?
Yeah, for sure.
Let's let folks kind of leave out. So, hey, I teach energy informatics, and but I haven't been putting it into hardware, and that's that's like the hard part. How can I get control over the buildings that we have at the University of Dayton? I really hope that we can get you in here, at least in some trial buildings, and I'm really going to be pushing hard for that.
Yeah, that's awesome.
It sure would be nice to be working with you to take what you're doing and turn it into real-time education for our students as they're helping to implement the kind of what you're doing. I'm really going to be pushing for that. We also had some people here from IGS Energy. It's an energy retailer in Ohio and actually Arizona and growing into a number of other states. And they were really interested in what you had to say. So they're going to be reaching out to you this evening. Really
great.
Impressive. I think you definitely showed you don't need to have a pilot higher and deeper letters after your name to be a genius. And
I appreciate that, Kevin. Yeah.
I think in terms of, you couldn't get where you were at had you not been touching hardware and had you not done audits and had you not done sales and, every aspect of that industry. And frankly, you can't teach that, it only comes through experience. I really credit you for knowing that was the direction you needed to go, or maybe you didn't.
Well, I mean, the challenge, I think, with younger people from what I've seen, like coming out of college is like just that, I just want to start a business. And it's like, but you don't have a problem to solve, right? Like I went to every aspect of this industry with the same problem, hoping I could solve it a different way. It's got to be a different company. It's got to be a different role. And it's just, you get to this point where you're the contrarian in every role. And
when you don't fit, if you're the only one, it's really hard to sell yourself because there's nobody out there that represents what you do. And so that actually is a big issue.
Nobody wants to do software.
Yeah, I guarantee you Emerson Climate Technologies, by the way, I think I'm recording this, but stop. So I'm not